Hi, welcome to the video tutorial for a lesson called Robots. There are a couple of versions of this lesson and it works really well if you do it creatively. And I've seen activities where people started outside, I've seen activities where people started in classroom, went onto the school field. But so now they do need to be all together at the start. You can do it in the classroom on paper, you could do it outside. It's just a thinking activity because you're making children think. Often children are familiar with things, but they've never had to think about them and compare things. So this is the example of this lesson of robots, and what the cartoon that starts this lesson involves a farmer who he's getting on a bit, she's getting on a bit, and he can't be bothered to feed the animals early in the morning in the winter, especially given how bad the snow was recently. So his two children think, well, we don't want to work on the farm, we don't want to get a wall house and feed the animals and get scruffy, so we're going to make you a robot. And the robot will feed the animals because all you need to do is drive along, dump the food and go. It's very easy. And they give him two robots to choose from. So that's the scenario of the lesson, but I would tell that after I've done the start. So I'm just going to show you how I've done the start in a classroom or in a hall. Okay? So I think it's best to start this lesson with the pupils around you, around some kind of map. So they're all on four sides, there are different directions to each other. And you say, well, what is it and what's this? So they quickly cotton on the fact that this is some kind of robot or something you've got to move to get to here. And so the question is, how could we direct this robot to there? And they will come up with all sorts of different suggestions, but you're already sowing the seed to what you'll think about, where some will say, let's use a compass. So it's always handy in this lesson to have compasses. So the last time I did this in the school, I borrowed the compasses from geography. So the idea is that we can go north, south, east, west. They'll give you all sorts of different suggestions, but others will say, let's go left, right, forward, back. And they can have a go at doing it. And obviously there's no scale on this map, so it brings in another level of complexity. And there is another version of the lesson where the children have to add scale to a map. So you might want to explore that, but as again, as I said at the start, there's no substitute for reading the plan and deciding on what you think is best mathematically for your pupils. These lessons work, but you have to interpret them for your pupils. Okay? This one works very, very well as an introduction to vectors. So I would always do this at the start of the topic, just to get the children to think. And I recently heard of someone who did this with the Year 11 class, and the children reflect, and this is a class that we're looking to get 4s and 5s in a few weeks' time, and they were saying they'd never actually thought about it before, and my thought was, my goodness, it's a bit late. So I think doing this in Year 7, it really, really gets the children to understand how we're thinking about space, how we're moving things around space. So the children are around here, they practice, they realise that, oh, what's my left is different to yours, but you don't need to say that, because that comes out in the main part of the lesson. So, in the robots lesson, the children have to make a decision as to which is the best robot for the farmer. The left-right robot with a face, or the north, south, east, west, the compass robot. And this is an example of the farm that they have to move the pupils around. They have to move the robot around. The example you're going to get, the first one, does have a grid line on it. So I don't use any questions with this, because all the pupils have got to do is direct the robot around the farm and decide which is the best. So at first they use the grid lines, so they've got to do it twice with the north, south, east, west robot and with the left, right robot. Move the robot from the start to the goats, to the donkeys, to the sheep, to the pigs, and they write the instructions. So forward 4, left 4, all that kind of stuff. And the question then is, which is the best robot for the farmer to buy? The children have to make a decision, and then they have to justify and articulate. Again, it's this focus on oracy and talking and explaining your thinking, because pupils have never had to explain the difference between relative form of giving directions and absolute, as in fixed, north never changes. And this is really fascinating because they know how to use a compass because it's in the curriculum for younger pupils, but they've not thought about the difference. And what is really interesting is when you have some pupils think the left-right robot is great because I know my left and my left never changes. So left, I don't wake up and my left hand moves, it's always there. And my right hand's always there. And the difference between that and an absolute, which is the compass. And it's the argument that's really interesting. And just drawing it out and letting them decide and say, and until at some point someone will say, right, stand up, sir, stand up, miss. And they're opposite to you and say, go left. And I go left and they go left and say, see, you went in the wrong way. You went a different way to me. And I'm saying, well, no, we both went left. And it's making them realise that left and right are dependent or relative to where you're facing. And north and south are absolute. And often they don't even know where north is. So it's a good activity to use the compass to find where north is in the classroom. Because again, convention always puts north pointing upwards on a map. What's that about? You need to move it to point to north. And some of them have never realised that north never changes. So that's often the lesson will end there. There is another aspect to the lesson, but you can then say to them, okay, if we think the left and right, the north and south robot is perfect for the farmer because it just goes there, it doesn't need to face. You just program it north, south, east, west, doesn't matter where it faces, it just goes there. You say, okay, give me directions to the swimming pool or the newsagents. Oh, you use left and right then because it's relative to where you are. And I think it's really, I just often share things about how I like to follow satellite navigation. I often do the overview so I can look at different angles that I'm coming from. I find this fascinating, this people thinking in left and right and how people view the world. So that's, for many classes, that's where the lesson would end. You can take it a step further and introduce vectors, because pupils will often say, well, really, we don't need to go on the grid, we can just go diagonally there. So this is then an opportunity for them to practice using protractors, to practice measuring angles. They can even estimate the angles. So this aspect of the lesson now moves on to is, well, okay, if we're starting here and we want to go here, we can just go straight there. And you could then tell them, measuring from 0 from north and working out that angle there, which to me looks like it's 110. They could estimate, they could measure it accurately, and then explore that way of directing the robot around the pond. I just think it's a lovely continuum where you're going from getting them to think about left and right versus north and south, to getting them to think about angles as a frozen turn, bearings, vectors, moving things around so that you've got a distance and you've got a direction that you're going in. I mean, it's lovely to use this one to get into practice using protractors to become accurate, and you could focus on, actually, if you're not very accurate, this method is really difficult because you just go right off track. And there are a range of questions you could use at the end, like which form of direction would you use in which different scenario. So a very active lesson. I've enjoyed it most when I've taken the children outside, or we've got them moving around the classroom and giving each other directions. So let's move, let's whatever I tell you to do the opposite. So actually direct pupils around the classroom. You could even use it with a compass as well. But there is an alternative version where the children have to choose the best route to decontaminate some poison on an island, and they've got to invent a scale. It's just a continuation of the same lesson, but I think this one is a really good starting point to introduce a whole topic on bearings, as I've said.